One final piece we need to be able to calculate the entropy all the way from 0 Kelvin is, of course, as we saw in the last video, we can't actually measure the heat capacity all the way down to 0 Kelvin. You can't get a substance down to absolute zero. And so we need an approximation for very low temperatures. So here we're talking about something less than, say, 10 Kelvin or so, maybe 10 to 20 Kelvin, depending on the substance and your data that you have. And so what this looks like, and this is, if you look at section 21-4 in your textbook, it goes over this. There is a theoretical framework to state that the heat capacity of a solid as it approaches 0 Kelvin, the heat capacity approaches zero as the as the temperature approaches 0 Kelvin. And more specifically, as the temperature approaches 0 Kelvin, that the constant pressure heat capacity is proportional to the cube of the temperature as you get close to 0 Kelvin. And so there is an equation that was developed by Peter Debye that the molar heat capacity, Cp bar, as a function of temperature for something at these low temperatures is 12 pi to the 4th over 5 times the gas constant times T divided by this variable called theta d cubed, right? So this is this T to the third the T to the third relationship that we see here. Theta d has units of temperature and it's called the Debye temperature, and this would be something you would need to find for your particular solid that you're considering. In practice, what you can do is say, okay, well, if I know that it's related to this T to the third, if I can measure, maybe down to like, 2 Kelvin or 5 Kelvin or whatever, and have data, along here, then you can extrapolate from here and say, okay, this follows a T cubed function, right? So if we're looking at constant pressure heat capacity, molar value, and say, okay, then our heat capacity as a function of temperature is some constant A times T cubed that we can get from this empirical fit. And so that's in practice how you get around the fact that you can't actually measure all the way down to absolute zero. And so this lets you get heat capacities all the way from 0 Kelvin at that third law limit up to, and you can get an absolute entropy up to any arbitrary temperature that you measure up to.